Okay, so perhaps we want some sort of definite answer or a definite integral. So say, for example, we have a curve that looks a little bit like this, something like this. And we're going to call that f of x again equals x cubed. But now we only want to find the area between here and here, if we call this b and a. What we can say is to find this area, of course, we need to integrate f of x, but we can actually define the two upper and lower limits. So that would be our b and our a. So the integral of x cubed with respect to x, because we're going along this axis, will then equal, so we want to add 1 to the power and divide by the new power. So that would then equal um, b a, so that would be 1 over 4 x to the power of 4. And we now have an answer, and we have a definite answer. So we don't actually need this plus c because we have this definite bounds of upper and lower. So what we can then say is, right, okay, how do we actually calculate what the final value would be? Well, we have to subtract the b value from the a value, which would mean our answer would be 1 over 4 b to the power of 4 minus 1 over 4 a to the power of 4. And that would be our definite integral. That would give us the exact area between these 2 points. This is really handy when doing some different types of calculation. So maybe we actually jump straight into an example. We have something along the lines of, this could be an exam style question. Evaluate between 4 and 1, the integral of 1 over x plus 3 with respect to x. So straight away we can see that we're going to have to do something quite tricky here. We'll call that squared actually. We'll make this 1 but then equal to a 4 and a 1, and we can say that x plus 3 to the minus 2 dx. We've just shown that if we've got something in this form, we have to do differentiation by or integration by substitution. So we can say our u value would be x plus 3. Therefore, our du by dx would equal x. Would just equal 1. And then we can see that if we have our u here would be u to the power of minus 2, which then if we were to integrate u dx, and then we can bring in our du by dx, we see that it's only 1, so that would be the same as say the integral of u du divided by 1, which doesn't matter, so it'd be u to the minus 2. Our integral for that would then be add 1 to the power, divide by the new tower, u minus u to the minus 1. So that would be our definite integral would be that plus c. So then we can put our equation back together and we would find that we sub u in, we'd have 1 over x plus 3, and it's a negative, so that would be our definite integral, our integral. But we know it's between 2 points, so it's between 4 and 1. Therefore, we don't need this c that we previously just had. So what we can now say is, if we stick our numbers of 4 and 1 back in, we have minus 1 over 4 plus 3 minus 1 over, minus 1 over 1 plus 3. And then we throw that into our calculator, we would get something along the lines of that would be minus 1 over 7 plus a quarter. So our answer would be 3 over 28. So what this would mean is on this curve itself, between 4 and 1, the area underneath will be 3/28. So this can be a little bit confusing sometimes because perhaps we can actually get an area of 0. So what do I mean by that? So if we were to plot the plot of double axis, we have our x and our y here. If we were to plot a function of maybe x to the power of 4, or maybe it's something cubic would be better. So maybe we say equals 4x cubed. We would know it looks a little bit like this, where it crosses through 0 and it has a line of symmetry. So that would mean if we were to look between the two differences of either from here to here, and we were to integrate between our, maybe we take a 2 and we take a 1 here, and we have a 1 here and a 2 here, we would actually find that because of the symmetry, if we were to do our integral, we'd actually get 0. So I'll show this what I mean. So if we integrate between our lower section of minus 2 and 1 of 4x cubed dx, we would say that that would be equal to, add 1 to the power and divide by the new power, x 4, divided by 4, so 4 over 4, and that would be to minus 2 and 1, minus 1 and 2, which would then mean that we would have 1 squared, 1 to the power of 4, minus 2 to the power of 4, which would be 16. So our answer would be negative 15. And likewise, if we were then to do the same, where we were to say that this was between 2 and 1, and we got the same answer of 4x cubed dx, we know that would be x to the power of 4, and that would be between 2 and 1. If we stuck our numbers in here, we know we would get the answer of positive 15. Therefore, we could see that actually, if we were integrating between either of these values, we have a line of symmetry. And likewise now, if we were to integrate between the integral of minus 2 and 2, and 2 and minus 2, 2 and minus 2 of the same function, 4x cubed dx, that would give us x to the 4, 2 minus 2, and that would mean that we would have 16 minus 16. So our integral would be 0. It's perfectly okay to integrate to get an answer of 0. So we'll leave it there for this bit, and then we're going to actually look at how correct this is and what are some other types of examples you might have